Well, hello everybody. I am Mr. Peer, and we are going to go over last night's homework, well, actually Friday's homework, and then go on to the next section.
Imposter! You are not Mr. Peer.
Oh
Sorry about that, guys. I don't know who that dude was. We are indeed checking page 431 to start with today. By the way, before we get started, I want everybody to make sure your name is on your paper and pass it up to the front, and my sub, whoever that may be, will collect those papers and put them on my desk. So pass them up. I'll pause and wait for you to pass them up. Hopefully that was enough time for you to pass them up. If not, then the video can be paused momentarily again if necessary. All right. We're looking at page 431, starting with number 2. We've got a triangle with sides of 3, 4, and 5. Oh, that's a familiar. What is this? This is not what I want right now. Hold on. I didn't properly prepare this, and I don't have time to start over, so we'll just make some changes here. Okay, we're good to go. Now, you should recognize what's true about a triangle with sides of 3, 4, and 5. If it has sides of 3, 4, and 5, then what kind of, I gave it away. What kind of triangle, I'm struggling here, folks. What kind of triangle does that have to be? Yes, I heard that. It has to be a right triangle, because 3 squared plus 4 squared is indeed 5 squared, so it has to be a right triangle. So that means that they've already given us the base and the height. The base is 3, the height is 4. The area of a triangle is 1/2 times the base times the height. So we have 1/2 times the base of 3 times the height of 4. Now, the trick with that is there's nothing that says you have to do it in that order. Yeah, you could do 3 times 4, 12, and then take half of 12, 6, yes. Or you could take half of 4, 2. 2 times 3 is still 6, yes. Or you could even, if you wanted to torture yourself or challenge yourself to use the fractions, you could do half of 3, that's 1/2. And guess what 1/2 times 4 is? It'll be 6. No matter how you do it, no matter what order you do this in, it's going to be 6. By the way, what rule says we can rearrange this any way we want to? That would be the what law? A property. The commutative property says we can flip things around. All right, so that's all there is to that. This one is going to be 6. Number 4. Number four. We've got a rhombus. A rhombus. Love that word. We've got ourselves a rhombus. All these sides congruent. And it has diagonals of 4 and 6. So that's 4, and that is 6. Well, the formula for the area of a rhombus is 1/2 times diagonal number 1 times diagonal number 2. 1/2 d1 d2. Well, that makes it easy. From there, we have 1/2 times, and it doesn't matter which one is diagonal 1 and which one is diagonal 2, because, again, multiplication is, what's that word? It is commutative. So 1/2 times 4 times 6. And again, you can take half of 4, that's 2 times 6. Or take half of 6, that's 3 times 4. Or multiply 4 times 6 is 24, and take half of that. Any way you look at it, it's 12. One thing you must not do. You do not take half of both the 4 and the 6. That would be a tragic error. You take half of 4 or half of 6, but not both. And we get 12 any way you look at it. Number 6. We have an isosceles triangle this time. Okay. An isosceles triangle with sides of 10, 10, and the base is 16. We want to know what is its area. Now you might say, well, we don't have a formula for that. No, we don't. We don't need a formula for that. Watch this trick. It's an isosceles triangle. Let's throw in this. That makes each of these pieces 8 and 8. Now let's look at just this red triangle. Its base is 8. Do these numbers look kind of familiar? 5 times 2, 4 times 2. This must be 3 times 2. It must be 6. Suppose you don't notice that pattern. What do? If you don't notice the pattern, and you need to find out what this guy is, Pythagorean theorem. Call it x if you want. Now let's call it h for height. We have 8 squared plus the unknown h squared equals 10 squared. A squared plus b squared equals c squared. That's 64 plus h squared equals 100. Now what do? Subtract 64 from both sides. Subtracting 64, we have h squared equals 36. So if h squared is 36, then h must be 6. So once again, we found out that yes, indeed, the height is 6. Now we can use the fact that the area of any triangle is 1/2 base times height. And we're practically done. 1/2 times the base. The base of this whole thing is 16 times the height. The height is 6. Now you've got choices here. You can either take half of 16 and multiply that answer by 6, or take half of 6 and multiply that answer by 16. Or if you really wanted to, you could take 16 times 6 and take half of that. Easiest way, half of 16, that's 8. 8 times 6, 48. What if you had taken half of 6 instead? That would be 3. 3 times 16 is also 48. What if you did 16 times 6? You'd get an answer of 96. And take half of 96, and what do you get? 48. Again, the one thing you must not do. Do not take half of both of these. Taking half of both of these is like taking half twice. And taking half twice is the same thing as taking a fourth. And we're not supposed to take a fourth. We're just supposed to take half. Only take half once. Never twice. Just take half once. And we get 48. All right, let's move on to number 8. Oh, number 8's kind of cool. We got this thing that looks like home plate, or it looks like a little house, whatever you want to think of it as. Oh, that's pretty pitiful. Can I do better? A little bit better. No, that's still pitiful. Oh, I'm such a perfectionist. That's not bad. All right, so what do we got? We're told this is 8. Excuse me. This is 4. This is therefore also 4. We've got the sides here of 5 and 5. All right, now this one we definitely don't have a formula for. So what are we going to do about this? Well, we're going to break it into pieces that we can work with. Let's break it like that. What's the area of this bottom rectangle? The rectangle is base times width. Base times height, I should say. Length times width. 4 times 8. So the rectangle is 32. Obviously we're not done. Now we need the area of the triangle up here. The area of the triangle, well, what are we going to do about that? Well, how about if we try this little trick? Let's split this down the middle again, like we did on the previous problem. Now, let's look at this triangle for a moment. If the whole thing is 8, then this must be 4. Oh, there's that familiar pattern again for right triangles. If the hypotenuse is 5 and one leg is 4, the other leg has to be 3, because 4 squared plus 3 squared is indeed equal to 25. 5 squared. So now we know the height of this triangle. Now let's look at the green triangle. What's its area? The area of any triangle is 1/2 times base times height. That's 1/2 times the base, which is 8, times the height, which is 3. So I would take half of 8 is 4. 4 times 3 is 12. So that means this guy up here is 12. So the entire area of rectangle plus triangle must be 32 plus 12. It's got to be 44. 44 indeed. And we're done. Number 10. Yet another example here. We've got an isosceles triangle with a base of 10 and perimeter of 36. Well, that's interesting. An isosceles triangle with a base of 10 and a perimeter of 36. Well, what is perimeter? Perimeter is the distance around. Well, of that distance around, 10 of it is already used up right here. That leaves us with 26 to account for. Well, because it's isosceles, that 26 has to be split equally between these two, so it's got to be 13 and 13. Check in ourselves. Does that add up to 36? 13 and 13 is 26, and 10 more is 30. Yep, that works. Yep, it does. So now what? Well, again, and again. The area of any triangle is 1/2 base times height. We've got the base. It's 10. We don't know the height. But yes, we do. Yes, we do. Let's again look at just this triangle. See a pattern here? This is the third time that we've looked at a little piece of it here to figure out the missing part. This piece, if the whole thing is 10, this must be 5. Now this is another one of those patterns that you may have, hopefully you did, you may have memorized back in chapter 8. If one leg is 5 and the hypotenuse is 13, you might automatically, instantly know that the other leg has to be, somebody, anybody? Yes, I heard that. It's got to be 12. What if you didn't know that? Then we're stuck. No, you're not stuck. All you have to do is use a squared plus b squared equals c squared, our old familiar friend, the Pythagorean theorem. Let's call this h for height. We don't know what it is. 5 squared plus h squared equals 13 squared. What's 13 squared? 13 squared, anyone know what 13 squared is? Yes, 169, you're right. 169. That's, of course, 25, 5 squared. Subtract 25 from both sides, we get h squared equals 144. And if h squared is 144, then h must be 12. Ta-da! So any way you look at it, h is 12. We've got everything we need now. The area of the whole triangle, the area of the entire green triangle is 1/2 times base times height. That's 1/2 times the base, which is 10, times the height, which is 12. And again, you've got choices. You can take half of 10, that's 5 times 12. Or take half of 12, that's 6 times 10. Or multiply 10 times 12 and take half of that. No matter what you do, you're going to get 60. Hey, shall I say it once again? The one thing you must not do, oh please don't, you do not take half of both numbers. You take half of one or the other. Or you multiply them first and then take half. But you do not take half of both of them and then multiply. That's taking half twice. We're only supposed to take half once. So we get an area of 60. Congratulations. We move on to number 12. And 12, I believe, was the last one on the assignment. Yes, it was. We have this time, this one's tricky. We have an equilateral triangle. And we have a perimeter of 18. We want the area. Well, what do we do with that? I don't know. Oh, come on. Think about it. Take it one piece at a time. If the perimeter is 18, and it's an equilateral triangle, then each side has to be what? Oh, I see now. It's got to be 6. Yep, it's got to be 6. 6, 6, and 6, because the perimeter is 18, and it is indeed equilateral, so we are told. So each side has to be 6. I think I have an idea. What's your idea? I think we need to split it down the middle like we did before. You are right. We will split it right down the middle like this. That makes each piece here 3 and 3. And now remember, we've got to find out what this is. There are a couple ways we could do that. But the easiest way is to remember a very important detail from back in chapter 8, our favorite chapter. Mr. Peer, no, chapter 10 was our favorite chapter. Well, okay, maybe second favorite chapter, chapter 8. Where you may remember, in an equilateral triangle, each angle has to be 60, 60, and 60, which would be 30 and 30, total of 60. Now we have ourselves the famous 30-60 triangle. In a 30-60 triangle, how do you get from short leg to long leg? I remember. You multiply by square root of 2. No, you don't. You don't multiply by square root of 2. Don't be silly. Oh, yeah. We multiply by square root of 3. That's right. This is 3 square root of 3. I remember now. Yep, that was a long time ago, wasn't it? Yes, it was. Okay, so we now have everything we need. What's the area? Any triangle. 1/2 base times height. That's 1/2 times the base, which is the entire 6, times the height, which we now know is 3 square root of 3. But how do we do that? Oh, come on, think simple. 1/2 of 6 is 3. 3 times 3 is 9. 9 square root of 3, we're done. That's it. Oh, we could get an estimate. We can punch square root of 3 into the calculator. It's going to be 1 point something, 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 and then multiply that by 9. We can get a decimal approximation of the area, but it is irrational. It's irrational because we don't know the square root of 3. And we're done. That's the area right there. Bingo. Ta-da! We did it. Yes, we did. Yes, we did. All right, that's the end of the assignment. You've already turned your papers in. Thank you. And now we move on to the next section. I am flipping my book over to page 435, and we move on. Today, let me check the time. I've got to make sure I don't go past about 45 minutes. Yeah, I have enough time to finish. Yeah, we're doing good. All right, we're going to figure out the area of a, what's this thing? Keep thinking. Starts with T. TR. Triangle. I don't think that's a triangle, folks. Try again. TRA. It's a trapezoid. Yes, it's a trapezoid. Good job, you remembered. What's a trapezoid? It has one pair of parallel sides, and the other pair is not parallel. The height of the trapezoid, perpendicular to a side. I could have put that height any place. I could have put it here, or I could have put it here. I could have put it there. It doesn't matter. As long as it's perpendicular to the sides, it doesn't matter where I put it. I just put it here. And a trapezoid has two bases, which we will call base 1, B1, and base number 2, B2. B1 and B2. Now, let's figure out how to find the area of a trapezoid. Watch this. This is so clever. We're going to make a copy of this trapezoid. Look at that. Now we're going to take that copy and we're going to flip it around like this. Oops, dropped it. I hit that dead spot in the board. There we go. And now I'm going to move it over here like this and put the two together. What's that? Well, that's a parallelogram. Now, and I'm trying to remember here, did we talk about how to do the area of parallelogram yet? We must have. It was in the previous section. Where was it? Yes, we did the area of parallelogram. We did that together last Friday. Feels funny saying last Friday when I'm recording this on Thursday, but you know what I mean. So, for the area of a parallelogram, yes, this thing is now a parallelogram. The area of a parallelogram is base times height. So, what in the world is the base of this thing? How long is, we know what this is right here. That's B1. What's this? Oh yeah, that's just a copy of B2 that swung around here upside down. This is just B2. So what's my total base? Well, wouldn't that just be B1 plus B2? Yes, you are correct. It is B1 plus B2. So the base of this parallelogram is B1 plus B2. That B does not look, it looks like a lollipop upside down. B2, that's better. And what's the height of this parallelogram? Oh, it's just H, isn't it? Yep, it's just H. So the area of this whole thing is the base, B1 plus B2, times the height. That's how you do the area of any parallelogram. Base times height. But wait just a moment. Wait, I know what you're going to say. What am I going to say? You're going to say that we don't want the whole thing. We only want how much of it? We only want half of it. You are right. Good thinking. We don't want the entire H times B1 plus B2. We don't want the entire parallelogram. We will only want half of it. So what do? We just take half. And there we have the famous, hold on, I want to get rid of that other thing here. Bink. We have the famous formula for the area of any trapezoid. The area of a trapezoid is 1/2 times the height times the sum of the two bases. Or, maybe I can put it in a different language. Add the bases, multiply by the height, take half. Done. That's the formula for the area of any trapezoid. Let's see some examples of how that works. Okay, here's a good example. So the formula for a trapezoid, area equals 1/2 times the height times B1 plus B2. So we add the two bases. We add B1 plus B2. So we have what now? Area equals 1/2 times, wait a minute, what's the height? What's H? Oh, we're given the height. It's 7. 1/2 times 7 times 12 plus, what was the other base? 8. 12 plus 8. Add the bases. Add the bases. 12 plus 8. Well, that looks easy. Yes, it is easy. 12 plus 8 being 20. We have 1/2 times 7 times 20. Now we have the right to take half of 7, which is 3.5, and multiply 3.5 times 20. Or we could take 7 times 20 is 140, and take half of 140. That's not hard. But the easiest way is take half of 20. That's 10. 10 times 7 is 70. We have an area of 70. Hey, let's not lose sight of what that means. That means that if this guy is 12 units long, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and if it's 7 units high, 1, 2, 3, 4, 5, 6, 7, and if this is 8 units wide, 1, 2, 3, 4, 5, 6, 7, 8, and we broke that into little squares. I know my scale is way off, so it looks kind of wonky. But if I were to break this into little squares, the question is how many of these squares will fit inside that trapezoid? 70. 70 squares. So the area is 70 square units. 70 little squares. Now some of them are going to be like little triangular pieces, and you take one there and put it together with one down here to make it one square. But altogether we could get 70 square pieces inside that trapezoid. Another example. We'll check in the clock here. Okay, good. I've got about 10 minutes left before I have to say goodbye. All right. Oh, this time we have an isosceles trapezoid. Expect to see something like this on perhaps the test and definitely on the homework. If it's an isosceles trapezoid, we need to know the height. How in the world are we going to get the height? Try this trick. Aha, this is so clever. It is isosceles. I can put a height here, but I'm going to do something really clever. I'm also going to put a height here. Now, if this whole thing is 10, but this is 6, guess what this piece has to be here? This has to be 6. But the entire base is 10, so each of these pieces must be 2 and 2. So we have 6 plus 2 plus 2. Yep. Oh no, not this. No. Oh, you know this problem. Bummer. Now I have to wait for about 30 seconds for the board to come back. Oh, man, I'm looking forward to my new board next year. This is a pain. It's dead now. I've got to wait. We've got to wait. Maybe I can entertain you while we wait. Hey, this is Monday. Eclipse day. 88.5% coverage at 3:10. Don't look directly at it without protection, without your eclipse glasses. Or you can poke a hole in a piece of paper, hold it up to the sun, and look at the image of the eclipse on the ground. It's pretty cool. Okay. Is it back yet? Yes, it's back. Okay. Now, where were we? Oh, yes. Okay. So now we know that these two pieces must be 2s because it is isosceles, so both sides are identical. And the whole thing, we're told, was 10. And this has to be 6. So these have to be 2 and 2. Now to find the height, what are we going to do? We don't have a memorized pattern for a leg of 2 and a hypotenuse of 5. So we're going to have to go and resort to... Oh, I heard someone whisper it. Pythagorean theorem. A squared plus b squared equals c squared. So we have a squared, that's 2 squared, let's just write 4, plus h squared, b is h squared, equals c, the hypotenuse squared, we'll just write 25. Now we're trying to solve for h, so the next thing we have to do is subtract 4, so h squared is 21, and then take the square root, and we got a nice, ugly looking square root of 21. Congratulations. So the height is the square root of 21. Sorry it's so ugly, but that's the way real life is sometimes. It can be ugly. So now, what's the formula for the area of a trapezoid? 1/2 times the height times b1 plus b2. Just plug in the numbers and see what happens. So we have 1/2 times the height, which we just discovered is square root of 21, times the sum of the bases. That's 10 plus 6. That's 16. Now, if we're wise, we're not going to try to figure out how to take half of square root of 21, but we do take half of 16 instead. Half of 16 being 8. Carry over the square root of 21. We're done. Your area is 8 times the square root of 21. What's that mean? Well, the square root of 21 has got to be more than 4, but less than 5. It's going to be 4 point something 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 times 8, and that would tell us how many square units are inside that trapezoid. 8 square root of 21. And congratulations. All right, let's see. I've got more examples, I believe, here. Let's go on to my next page. Oh, no, there's a little green X that says that's my last example right there, which means we're done. That's it. So your assignment, yes, there is an assignment due tomorrow. Your assignment is page, here it is, 435, yep, 435, classroom exercises 1 through 3, and of course, someone's good. You mean all or evens? Would I say 1 through 3 even? No, you wouldn't, would you? No, that's 1 through 3, all, of course. And on page 436, the written exercises 2 through 8, even. That is due tomorrow. And by the way, if you find some of these problems to be somewhat challenging, take heart. The problems on the test will not be that bad. As long as you know the formulas, such as the area of a trapezoid, then you've got it made. And that's it. And I say goodbye until tomorrow.